So today's learning goal is, can you critically assess the concept of a scatter plot and determine the type of relationship, specifically linear correlations, right? So do you know what a linear correlation is? All right. So here are some relationships concepts. Does smoking cause cancer? Does your height affect your ability to estimate other people's height? Does your mark and sports have a relationship? Sometimes those relationships between two variables aren't that clear. Okay. Now, here's the thing that you need to know. We have an effective way to actually test to see if the relationship has a mathematical linear relationship, whether it is a strong linear relationship or weak linear relationship. Now, when we discuss the visual representation of a graph or plot, right, sometimes what happens is the nature, i.e., the relationship between the two variables gets shown, right? Now, that is usually shown through scatter plots because normally nature isn't a nice thing. It has an idea. If you think about it, there are things that follow a trend, but sometimes they don't. To measure these trends, what we do is we use a thing called a scatter plot. All right. So when you hear of a scatter plot, it's kind of like a mathematical diagram. Now, yes, it is a mathematical diagram or a graph, right? But it usually is displaying a thing called a relationship, otherwise known as a correlation. So in mathematics, a relationship or a correlation is the same thing. All we're doing is using these fancy words to make this up. Okay? Seriously, I can't make this up. All right. So now let's talk about this thing. It is called a graph. Now, my graph here is going to fit on this graph. Now, you'll notice that most of the information here kind of follows a trend, like it follows like a trend line. Okay, that was why you were studying how to go and graph points on a graph when you were studying for your provincial test. You had to be able to understand these things, right? Now, you'll notice that I might be following this trend, but there are some points that are kind of off of the line, but we kind of see that there's a trend of where all of our information is. Now, sometimes the information is skewed a bit. So these points that are way away from most of our information, it's called an outlier. So this is the graphical representation of a set of points or a set of numbers that don't quite fit what we're looking for, but most of them do. And when we have these outliers, those outliers affect the overall trending of information. And we as human beings love to be able to make predictions as to how certain things happen, right? That is why we love to look at math and love to look at data, because it allows us to go out in the world and predict what the universe is going to do. So just to finish this description of what a scatter plot is, it's a core that displays a relationship or a correlation between the values x and y of our graph. In this case, we have the process output against the quality characteristics, right? And that's all it is. We're just basically trying to find some way to come up with an equation that allows us to predict where all of this information is. A lot of people use this to make money or predict how a car will drive or things like that. Or use it to predict the wear and tear of a car over time or parts of a car. Or how about this? Your grandmother's replacement knee. things like that. So just remember these relationship things, they only relate to what we studied in grade 9 and 10. All right, so now let's go talk about some stuff that we learned a long time ago that we need to refresh ourselves with. All right, a long time ago, you learned about a thing called an independent variable. The first thing that we're going to look at is this thing called the independent variable. These are the variables that we can control or the things that we're actually investigating. Okay, so those are the important things that influence other things. Okay, that is what it is. And that's why we always had our x values on the bottom portion of our graph. And whatever we chose for x produced a y. So guess what do you think the dependent variables are? So when we're talking about this thing called a dependent variable, right? These are variables that can't be controlled, but are affected by the first variable x that we talked about before. For example, the cost that you pay for a cell phone service is affected by the time you spend on the phone or the services you use, not uses. Now, the controlling factor here might be the time or the services chosen. So you want to always think of this as y equals or cost equals or something like that. So the x variable is chosen and everything on the right side of that equation controls what happens with y. For the word correlation, all you just need to remember is it's just the mathematical relationship or the rules that allow x and y working together, whether it be a linear relationship, a quadratic relationship, a cubic, quintic, anything, right? As long as you can find some relationship that allows you to predict where something is placed. That is what a correlation is. And the stronger the correlation, to either linear, quadratic, quintic, whatever, the closer the points are to the line that represents the relationship that we see. So now when we talk about a linear correlation, this is funny. Remember, a linear correlation really is a linear relationship, right? So when we talk about a linear relationship, we're literally talking about this thing. Some relationship of points for which we come up with an equation in the form y is equal to mx plus b, where x is in the independent variable and y is the dependent variable. So when you think of a linear correlation, this is all it is. You just need to remember that the relationship is just a line. The relationship between x and y is just a line. That's all you need to remember. So when we talk of a scatter plot, right, and we're looking for a line of best fit, the line of best fit for this situation here that we have is this line here. We could come up with an equation for this line based on its y-intercept and its slope. Now, you'll notice that most of the points are very, very close to those things, and some of them go directly through. That is what we call a line of best fit. So basically, you learn stuff in grade 10 that you're going to eventually use in grade 12. Isn't it awesome? So let's take a look at classifying correlations. Okay, now I'm assuming that you remember all about slope, right? Now, if I was trying to draw a line through these points, you'd notice that the points would literally touch every single value on the line. And we call this a strong linear relationship. Okay, it's strong because all the points are actually touching the line. Now we can also say that this is a positive or a negative relationship. This is a negative relationship because it's slanting downwards as we go from left to right. Now, this next one to the right of it, B, if I drew another line of best fit that kind of went through as many points as possible, would say that I wouldn't say that this is strong. I would say that this is basically a weak relationship. Now, here's the thing. We're talking about linear correlations, right? And I told you that the word correlation and relationship are the same. So you're going to say, when you do these problems, you're going to say this is a strong. So for the first one, you're going to say this is a strong negative correlation. Negative, correlation. Now this other one here, since the points are kind of okay, they're kind of close, I would say this is a weak negative correlation. Now, the reason why it's negative is because the slope of the line is negative. Now, when we look at this third one over here, we're like, what? There's no line that we could draw that works for it. That works for all of them. Maybe this way? Nope. So this is where you say there is no correlation. ION. So there's no correlation between the information on the graph. For this next graph here, D, you'll notice that the line touches everything. So we're going to say this is a strong positive correlation. Now, for this next one, E, we wouldn't say it's a strong positive correlation. We wouldn't say it's strong positive. This would be a weak positive correlation because we kind of can see there's a trend line. So this is a weak positive correlation. And then for the last one, oh my goodness. There is no linear correlation for this last one. This is a non-linear. This might actually be a quadratic. You never know. So you'd say this is a non-linear correlation, but it does follow some trend. That's why we say it's non-linear, but it does follow a trend. Notice the third value that we were looking up here was no correlation because we couldn't find any linear correlation, but we did find not a line, but a curve that the points follow in the last one. All right, and that's your review of grade 9. So let's move on to the next thing. Now, in math, we study the concept of covariance, right? Now, covariance in this case, instead of, remember when we had variance, we had something that looked like this. The sum of x minus x bar divided by n, and we squared that bit, right? So when we're trying to find the coefficient between two variables, mathematicians came up with, instead of having x minus x bar, you have x minus x bar times y minus y bar, with a degree of freedom that is shrunk by 1. Because what's happening is you've got two variables that are kind of commingling when you're doing your calculations here, right? Now, here's the thing. Each of those variables, this is called the covariance of two variables, right? So we have the covariance of x and the covariance of y, where you know the following. Where our variable x is the independent data point, i.e. the x variable, the thing we care about, and y is the dependent data point. And then we have x, which is the mean of the x's. And we have y bar being the mean of y's data points. And then n is the number of data that's collected. So now finally, when we're actually using this, we have this R coefficient, right? This R coefficient tells us how close this thing is to a line. Now, let me explain to you what this S of x times S of y stands for in this basic equation right here. So this R thing, some of us call it the residual. And what the residual tells us is how close something is to a straight line, i.e., how strongly correlated the data is. It literally kind of measures the distance of all of the points and kind of aggregates them to tell you how close the points are to the line, how strongly attracted they are to the line. Now, in mathematics, yes, they call it the residual. We do call it the residual, but for our class, we're going to call this in the textbook, you're going to call this the correlation coefficient. So now, let's see what we can do or what this actually means. So when we talk about the correlation coefficient, what it actually means is this. The correlation coefficient gives a number between -1 and +1. Where the following occurs. If we have a 0, there is no correlation. There's no relationship between the x and the y variables. So here's what we're going to do. We're going to break this up into thirds. So if we're at, say, 0.33 and 0.66 and then 1 and then -0.33 and then -0.66, whether you are above or below, between +0.33 and -3.33, we have weak relationships between here and here. Anything that is in between 0.3 and 0.6, we say this is a moderate relationship, and the same can said being on the negative side. Now, if we have something that's ridiculously close to 1, this is a strong relationship. Now, here's the last bit you need to understand. I'm just going to move this up. Okay, so here's the deal. For anything that's in this side, this is a positive correlation. But you would say it's either a positive, strong, weak, or moderate correlation. And then everything to this side here is a negative correlation. Now, please remember your positive and negative correlations from before. If we take a look at what we studied before with our slopes of lines, right? Positive correlations and negative correlations are what you see on this chart here. Are what you see on this chart here. So basically we have these and these are negative. Okay, so this would be a weak positive. So you'd get a number of 0.15 in the positive direction. This would be a weak positive, weak negative. So you get 0.15 as the negative in that relationship that we were talking about at the bottom of this sheet here. All right, so now let's move on to our next topic. So imagine if we have a problem like this. We have to take some information, i.e. the stuff from this farmer and his yields of wheat crop, okay? So the farmer wants to determine whether there's a relationship between the mean and the temperature during the growing season and the size of his wheat crop. After following, using the given, after the following, using the given information, basically what he did was he wanted you to determine the correlation of the data. In order to calculate the correlation of the data, what we have to do is we have to basically make a table of values, and we can do this by hand or we can do this by calculating it in an Excel spreadsheet. Now, I'm going to show you how to do it as a calculation in your spreadsheet, and then we'll just do the overall description of what the final answers are. Okay, so now we're going to go to a video that explains how to do the correlation. And then once the correlation is done, there's another video that talks about how to do the correlation for coefficient using your Excel spreadsheets or Google spreadsheets. So remember, I want you to do these ones using Google spreadsheets. Now those Google spreadsheets, when you use them, it kind of shows you how you would have to do this by hand because you've already done the standard deviation, right? So the standard deviation is kind of what we're doing here over and over again. All right, so I'm going to let you go. You're going to see the video and then we're going to come back and do this final project. All right, so for this topic, what happens is we're going to go and calculate this thing called the correlation. All right, to calculate the correlation, we have to use this equation that we have here. Okay, now that equation, though it is important, you have to basically make sure that all your data is actually in your spreadsheet. Now, upon creating your spreadsheet, you'll notice that our original equation for our correlation was given by x minus mean and then the y minus means, and then you have to times them. So we have to actually build that up in our equation sheet. So in order to do that, we actually have to use the average function. So you go and hit average and then bracket, and then what you do is select all of the cells that you need for the calculation. Then you hit enter to commit the changes. So that means the mean for x is 8. So we're going to do the same thing for our y values. Now, the moment that we've done that for our y values, you'll notice that our equation that we had over here, we actually have to go back and calculate the means minus the x's, and then the means minus the y, the mean minus the y's. So here's how you do that. So you click equals in the cell that you're working at, then you go to your original x value, and then you subtract its mean. Now, to do that, you click minus, you type minus, right? And then you click on your mean bracket. Now you notice I'm having a little trouble here. So I go minus, and I click the mean section. And then in order to make this be an absolute reference, so it always refers to the mean section, which is D8, you actually have to hit F4. So when you hit F4, it changes the lettering for D8 to $D$8. Then we can copy that information down with the information toggle that we studied, that I taught you about earlier in the previous lessons. And then we do the same again for our y's. So do the same thing for y's, where we go and say C2 minus C8 and then hit F4. And then it makes it an absolute reference. Click the right bottom toggle and copy your information down in your sheet. So now in our equation, we still have to make sure that we multiply the x minus the mean, and the y minus the mean. So in order to save our time, all we're going to do is we're going to hit equals, click the data that's in the mean column, then times it by the stuff in the mean y's column. So then you hit equals, and there you go. And then we copy the information down by clicking the bottom right toggle and dragging down. And there we go. Oh, still having issues. Yeah, there we go. So now, in order to calculate that, now we actually have to sum all those times things that we did from before for the correlation. So we got to do that first, and then we have to divide by 5. So now we sum all that information and select all our information, hit enter to commit the changes, and now we have our sum. Now, some computers, when you go and type sum, it automatically just grabs all the information directly above it. Sometimes it doesn't, so you actually have to do this selection. So now once you've hit that selection, you hit enter. Okay? So now that you've hit enter, there's your sum of your correlations. So now what you're going to do for your sum of your correlations is you're going to go and scale it down by typing 1 divided by the n value. So remember, the n value was 6. The total number of points was 6. Okay, so now that we have that, we're going to go back and we're going to say, all right, 1 divided by n by the sum of the correlations. So you go and calculate that right now. So we're going to go, all right, there's our correlation of x and y. And here's what we do. We go in here and we go equals 1 over, instead of 6, we're going to divide by 5. And then we're going to times it by our correlation, our sum of correlations. Okay? So equals 1 over 5 times 2.1. Hit enter. And that will give us the sum of our correlations. And it's 0.42. Doesn't really tell us much, but it will tell us when we go to part B of the problem. So that was how we calculated part A's solution, the correlation of x and y. So it's very important to be able to do that. Now you can do this by hand, or you could do this by spreadsheet, right? And I do find the spreadsheet calculations to be a lot nicer, because you can quickly get the answers up there and get your work done. Okay, So now let's go on to the residual, what I called the residual before. So think of the residual as telling us how close to a line all our points fit. Okay, so it kind of gives us an idea of whether it's a moderate solution, positive, or a moderate solution, a weak solution, a strong solution, i.e. all the points are very close, or a positive relationship or a negative relationship. Okay, so in order to get this information working, what we literally have to do for this problem is we have to go and figure out the S of X on the bottom, because we already have the S of XY on the top, right? We already calculated that. There's no real reason. So we got to calculate the S of X and the S of Y. So the S of X is just basically X minus the mean squared divided by N, right? So that comes from our variance and then our square root of the variance. So let's go and do that. So we have to calculate X times X minus the mean of X and square it, right? In order to get that, what we're going to have to do is we're going to have to take information from the mean of X and the mean of Y. And the X minus the mean of X and the the Y minus the mean of Y. So this is the calculation for it. To do that, we have to go under the X minus mean and squared. We're going to go and go to the section where we have our mean of X, and we're going to times that by itself. Get an answer. That's 16. Negative 4 times negative 4 is 16. Then we copy that information down, and that gives us the sum of our squares. So that gives us our squares. So now we got to figure out the sum of our squares in order to calculate our variance. So we sum up all the cells above to get 34. So now we have to calculate the variance. So now that I calculate my variance, I divide by the total number, which is 6. So that means we have 5.6667, right? So now to get the standard deviation, all we have to do is take the square root of the variance. So the square root of the variance, right, is going to be this. To do that, you have to use the square root function with an open bracket, then hit the cell where the variance is, and you're done. So that's your standard deviation of X, right? So one more time, square root, the number above, hit enter to commit, and there is your answer, 2.3804, okay? So now, let's move on to the mean of Y. The mean minus the mean of Y squared. So let's do the same thing again that we did before. And so now what we're going to do is we basically follow the same pattern that we did before. Okay. And what we're going to do is we're multiplying our y's and then copying down our information, then calculating the sum of the squares of the y's, right? Which equals the sum of everything above it. And hit enter. And you are ready to calculate the variance of y. And so the variance of y is just 1 divided by, you guessed it, 6. And then for the last part, we have to square root our values. So we go equals 1 divided by 6. Well, not 1 divided by 6, but the square root of that information. So now that is the standard deviation of X and Y. Now we're still, so we got the components for the top and the components for the bottom of our equation, okay, of our residual. So now let's go and figure out what the residual is. The residual is what we call the correlation coefficient that we studied before, right? So what I'm going to do is I'm going to highlight where my calculation is going to be. And what you're going to do is you're going to basically make it bold, and you go, okay, so here's the correlation coefficient. So here's what we have to do. We have to take S of xy, which was our correlation of x and y. Then what we have to do is divide by, put this stuff in brackets because we have to multiply those two things first and then divide. So we're going to have to click on the standard deviation of x, and then we're going to times that by the standard deviation of y, and then hit an open bracket and then hit enter. And you're done. Now we've got all the information that we need. All right. So if you think about it, this portion of our problem was part A. This portion of our problem here was part B. Now, based on what we studied with the correlation coefficient, right? You go and look at that chart that talks about all the stuff about the correlation coefficient, and then you are done. Okay? All right. And we'll summarize this at the end of the lesson. Doing this problem, in order to solve part A from our video, basically we had to calculate the correlation, right? So let's just summarize that. So for part A, we literally had to calculate SXY when we're talking about the correlation. So that was this part of our calculations that we did on the computer today. Okay, so here's what we're going to do. So we had to calculate our correlation data, our correlation. So we calculated our correlation, and the correlation of XY was computed right here. Okay, now you can do that by hand at any time. When we're doing math work, you can do that by hand if you'd like. It's not a problem. Now, the next thing that we had to do is it said determine the correlation coefficient, right? So for part B, this is what we have. So for parts B's calculation, we had to calculate this thing, the residual, otherwise known as the correlation coefficient, right? So the correlation coefficient is SXY, which is what we calculated in part A. And then we had to just basically square the means. So for this one, this is the square of that. And we followed the pattern, and then we got our sum of squares. Then we took our variance, which was dividing by the n value. So when we div by n, and then for this last one, this last bit here, we square root the variance that we calculated in the previous line. Then we put it all together, and we follow this pattern to put our answer in here. Now remember, when we did that, we had S of X and Y, and then we had to put it as a division of, in brackets, SX times SY in order to get our answers correct. And you would have to follow that same pattern for your calculations on your phone or your calculator. And now for part C, it says determine what conclusions can be made from your results. So remember, from our description of the relationships, that chart that said we either had a weak, a moderate, or a strong relationship, this is what you said. Because this number of 0.56 is between 0.33 and 0.66, this is a moderate positive linear relationship. Now, the reason why it's positive is because our residual is positive. And remember, this is a moderate linear relationship. Remember, the residual helps us figure out how close to a line our data fits. And that's it. We're done. So now you'll have some work that I want you to do for this unit. Good luck. Now, I want you to do the homework that I've provided. for you, which is online. But then as an exit task, I have a problem for you that I'm posting online. Make sure you actually sub that you do this one by hand. But then make sure you check your answers using an Excel spreadsheet or a Google spreadsheet. And you'll have instructions on how to share that information or upload it for me. Okay, you'll be able to do all of that as our exit task for this part of the lesson.